to be kind of having those problems on your homework assignment and doing a little bit of reteaching as we go through. So one of the things that I saw as one of the biggest issues that people had with the quiz is with the triangles that had some congruency marks on them. In these triangles, do you notice that all of them have angle congruency marks? All of them have the little marks in the corners telling them that the angles are congruent. One of the things that we talked about is if a triangle has two congruent angles, it also has two congruent sides. If a triangle has three congruent angles, it has three congruent sides, and vice versa. The key thing is knowing which ones are congruent. So, focusing in on the first one, how many congruent angles? Three. How many congruent sides? I can put a tick mark on all of these. What does congruent mean? They're all equal to one another. These are side lengths. Do side lengths add up to anything? No, far too many people tried to add up side lengths and say sides add up to 180. Sides add up to nothing. Sides, the only thing you can know about them is if they're equal. Now, all three of these are equal, which means I could write an equation, an extended equation if I wanted, with multiple equal signs, except do we typically solve something like this? No. How many equal signs do we typically work with? Just one equal sign. Which means I can ignore any of these three. Since all three of them are equal, I only need two of them. Which one looks the hardest to work with? Ignore it. There's your equation solved. A lot of people did. Okay, question B. How many congruent marks? Two, which means how many congruent sides? Two. The key thing is knowing which ones. It's always the ones across from the angles, which might help you out by saying which ones it's not. If it's the ones across that are congruent, then the one between is not. Which side is between those two congruent angles? The 6 is there to throw you off. -1 plus x equals 7. And then you solve. Question C. How many congruent angles? 2, which means how many congruent sides? 2. The one in between is not the one you want. Which one's in between? The 6. The 6 is there to throw you off. The other ones are the congruent ones. And if they're congruent, they are equal. You set them equal, and then you solve. How many congruent angles? 3, which means how many congruent sides? 3. All three of them are congruent. When it's all three of them, do I need all three of them? No, I need 2 of them. Pick whichever 2 you want. I think the 8 looks the easiest to work with. We could set 8 equal to which other one? I like x plus 19. And then you would solve. So, last 4 problems. We set up the equations. You can solve them on your own. Okay. If you have not already grabbed it out, you should grab out your notes packet and your 3 postulate sheets. You don't actually need a calculator for today. I kind of assumed you were getting one for the other stuff. That's why I didn't question your time. Okay. So, I'm going to start with the green postulate sheet, and then we're going to shift over to working with our notes. First thing I want to talk about is I want to talk about one of the properties that we came across yesterday, but we used it in a different way, and that's the reflexive property. The reflexive property says something is congruent to itself. We're going to add a little note. Yesterday we used this when the two triangles shared the same side or shared the same angle. So we can use when triangles have shared sides or angles. I do recommend that you write this down on your green postulate sheet. During work time, I will let you see mine. But keep in mind that we also didn't write everything into our postulate sheet. There's one other thing on the postulate sheet that we are going to add today on the other side, though. And it was the main postulate that we used yesterday, and it was the side angle side congruence postulate. Now, base angles and converse of base angles theorem, we've done both of those. I'm not writing them in, you can write them in yourself. But yesterday we talked about side angle side postulate, where we had situations like AB was congruent to DE. BC was congruent to EF. And if we also had the angle between those two sides, which was angle B congruent to angle E. When we had two congruent sides and a congruent angle between them, key thing, it has to be between them, we had the situation for the side angle side postulate, which went in proofs as SAS, and we were allowed to say the triangles were congruent. In this case, it would be triangle ABC is congruent to triangle DEF. That was the postulate that we focused in on yesterday as we were going through and we started doing our triangle proofs. Now, as I did this, I pointed out that our goal within our proofs yesterday, if you're trying to prove triangles are congruent, because that's what the proofs in this chapter are going to all have. If you're trying to prove triangles are congruent, your goal was to get 3 congruence statements inside of your proof. Yesterday's focus was 2 sides and the angle between. Today, I'm giving you other options of mixtures of 3 congruences that will get you to what you want. Today, we're on page 13 of our notes, proving triangles congruent by the side-side-side congruence postulate. The side-side-side congruence postulate is similar to the side angle side congruence postulate. First off, in a proof, side-side-side is SSS. And it requires 3 sides of one triangle being congruent to 3 sides of another triangle. So if we have the situation where AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then we will have congruent triangles. There are technically 5. We're going to do 4. There are 4 different ways that we're going to be able to prove that triangles are congruent, all of which have a combination of 3 sides and angles, but which 3 is going to be very specific. It has to be specific setups. Some setups of sides and angle combinations will not work. The 2 that we know work so far are side, angle, side, 2 sides and the angle between, and now we're adding side, side, side. If we have a situation where all 3 sides of a triangle are congruent to all 3 sides of another triangle, then the triangles are congruent. Triangle ABC is congruent to triangle A, being between the single and the triple, would match up with D between the single and the triple. B, between the single and the double, would be like E. And F, between the double and the triple, matches up with C between the double and the triple. So triangle ABC is congruent to triangle DEF. Now yesterday I pointed out that chapter 5 proofs, for a lot of people, these become their easiest proofs to do for multiple reasons. One, because they all look very similar to one another, and two, because they're all a lot shorter. What was the longest proof that we came across yesterday? How many steps? It wasn't 7. It's 5. Yesterday's longest proof was 5 steps. 4 and 5 are common lengths of these proofs, because there's only 3 sides, and oftentimes you're given some of that information. Now, similar to previous proofs, we always start with our givens. Yesterday I also gave you one other piece of advice. When you have a congruent inside your statements, make sure that your picture has tick marks on it, or angle marks if it's angles. KL is congruent to NL. Do you notice it's already got single tick marks there? Sweet. KM is congruent to NM. Also had tick marks there already. Most of the time it won't have the tick marks for you. But put them on the picture. That's going to help you differentiate between when you use side angle side, 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 and then the other two that we haven't talked about yet. Chapter 5 is when a lot of people move away from doing the 5 things that you look for in your proof, but you still can use the 5 things. What's the first thing you should look for in your proofs? Words. Are there words in my proof? No. So I move on. What's the second thing we look for? Symbols. Are there symbols? Technically, yes. There's congruent symbols, but what did we say was a change with congruent symbols? We want them. We keep them. We are happy they are there, because how many congruent symbols do I want again? 3. Both side angle side and side 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 have 3 congruent symbols. So I want 3 congruent symbols. They have 3 congruent symbols in the if to clarify. That will lead me to where I'm trying to go. I already have 2 of my 3. Okay. Words, symbols. Third thing. Substitution and transitive property. It can come up in these ones, but it requires 2 congruent statements, or 2 equal signs. We want congruent statements that have the exact same thing in them. Are KL, NL, KM, or NM all the exact same thing? Any of them? No. We move on. Is there ever going to be algebra with congruent statements? No. The 5th thing we look at is pictures. In our previous postulate sheets, we had 2 sections that talked about from pictures. Supplementary, while it can come up, is it what we want? No. Vertical angles is congruent, so maybe, but are there vertical angles in that picture? No. Adding up segments can come up, but is it what we want? No. Adding up angles can come up, but is it what we want? No, we want congruence. There are no vertical angles. The other way, and we talked about it already a little bit today, is if the 2 triangles share either a side or an angle. Do my 2 triangles share anything? What do they share? They share the side LM. So I'm going to say it's congruent to itself. data, what property said something was congruent to itself again? Reflexive property. Reflex. Congruent symbol here. Make sure you mark it on the picture. How many congruent symbols do I have? Currently have 3, so I'm thinking I've got the right setup. Now, when you do this, side angle side can still come up. So that means you need to look at your triangles in your proof and see, do I have a setup like this where I have 2 sides and the angle between? Or now, do I have a setup like this where the congruents are the 3 sides? In this picture, 2 sides and the angle between or 3 sides? Side, side, and a side? Do you agree that those are all side lengths? None of them are angle marks? Which means by side, 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 the triangles are congruent. Triangle, KLM, is congruent to triangle, NLM. These proofs can be as short as 2 steps. 3 steps, what I meant to say. I have my proof, I move on. Okay. Two columns, one's S, one's R. Haley, how do I start every proof? Reasons given. Charlie, how many givens do I have in this proof? One, 2, 3. That's not given. I have 3 givens here. One of the not most common errors, but one common error that I've seen in this class is that people miss a given. Or they'll put in the prove as a given. The thing you're trying to prove is not given to you. Okay, I see congruent symbols in my proof. I make sure they're in my picture. Kylie, is RS marked as PT, or marked congruent to PT in the picture already? Do you see tick marks on the picture already, in other words? For RS and PT? RS, got a single tick mark. PT, got a single tick mark. Yeah. Jackson, what about QT and ST? Or sorry, QS. I said it wrong. Sweet. If they don't have them, put them on there. It's going to help with certain things as we move forward. Okay, Q is the midpoint. That one doesn't get marked on a picture. But, Nate, what does a midpoint tell me? So Q, the midpoint of RP, grab your orange postulate sheet if need be. The orange one's the one that's got midpoint on it. According to this, if I see something's a midpoint, I can write in a proof.
It's
that I have congruent segments. I just have to figure out which segments are congruent. In a midpoint problem, it's going to tell you this is the midpoint and this is the segment that it's the midpoint of. Midpoint means middle point, which means that point is breaking it up into two congruent segments. Cam, what are the names of the two segments that are congruent if Q is the midpoint of RP? Q breaks up the segment. Here was the segment. What are its two parts when I put Q in the middle of it? There's the top part and the bottom part. What's the top part's name? What's the bottom part's name? You got it. So, midpoint tells us that those two parts are the congruent parts. So RQ is congruent to QP. Definition of midpoint. I mark a congruent here. I mark it in the picture. Ava, do you notice anything about what's in our proof right now? There's three congruent symbols. When I see three congruent symbols, I start checking side, 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 or side, angle, side, because those are the two that I have right now. And it wouldn't be a bad idea to move side, side, side to your postulate sheet so you have them in one place here soon. The question is, does this fit either a side, 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 or a side, angle, side? I look at one triangle. How many sides are marked as congruent? 3. 3 sides. Wouldn't that be side, side, side? Double check that the other triangle is the exact same setup. Is the other triangle 3 sides? Then it is side, side, side. I have the side, side, side setup. But Aiden, what do I actually write here in the statement? Don't forget the triangle symbol. But yes, triangle RSQ is congruent to triangle PTQ. Aaliyah. Where'd that come from? Where did Aiden get it? So you can say side, 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 angle, side when you say our triangles are congruent. Those two go hand in hand. Knowing exactly what goes here comes from the proof. That's where that came from. When you noticed you had 3 things that fit side, 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 you could say the triangles were congruent. The order it wants the triangles in is what's in the proof. Do you notice the next page switches over to section 5.6? That's it for notes today. Yeah, notes are short today. It wouldn't be a bad idea that you take the time to fill in side, side, side on your postulate sheet. Based on what we did in our notes. Okay. I didn't write down the homework yesterday because of my snafu of not knowing where the homework assignment was. So, I'm going to write that down quick. Yesterday we did section 5.3. Yesterday was the 5th. Our homework was from yesterday, was due on Thursday, which is the 7th, and it was the 5.3 worksheet. That was yesterday's stuff. If you have it written down, great. You did awesome. I didn't write it down. Today we did section 5.5. Today's the 6th. Our homework's due on Friday. Friday's the 8th. And it's the 5.5 worksheet.